rural development.
Okay. Well, I'm very proud that I can introduce you to a new European project, the Insignia project. And as you see, it's a pilot study on environmental monitoring of pesticide use through honeybees. That means we're talking about pesticides, we're talking about bees, but we're not talking about damage by pesticides, or we're not talking about bee diseases or whatever. We're talking about the honeybee colony as a tool, as another tool that you are used to have as a tool for pollination, as a tool for harvesting honey. Now I can show you where this project is about, the honeybee colony as a tool for monitoring the environment. And this study is promoted by the European Union and it will take 2 years. So, how can you use a honeybee colony as an environmental tool? Well, first, a honeybee colony is a biosampler. You see this one. It's a biosampler. What's biosampling? Biosampling means simply a living organism is sampling all kinds of materials outside. Now, we know our honeybee, she is also flying around, collecting pollen, collecting nectar, solely focused on the flower, but all kind of material that's also on this flower, from atmospheric deposition, airborne, or also plant pathogens are also present in the flowers, and bees collect them as well. They collect them, they bring it to the hive. You see how it's collected by the first and see, bees collect them very on the pistils, on the petals, and taking all the pollen, but also all the environmental pollution that's in it along with them. But then, all this material is in the first on the honeybee, but then in the hive. And then you have to sample them. And one of the aims of this Insignia project is to find out ways to sample the honeybee colony non-invasively. So that means that you get two ways of sampling, invasively, non-invasively. Now, invasively is what mostly been done. You kill the bees or you take food storage and it goes to the extent of the honeybee colony. But there are also new ways, and we want to explore this in this Insignia project by non-invasive subsampling. That means, how can you sample a honeybee colony without killing bees? How can you sample a honeybee colony without taking too much food, without taking too much pollen that goes to the extent of the honeybee colony? That's what we're going to do. This Insignia project has 7 work packages, and we're going to show you all. Let's start with the first one. It's the agriculture citizen science. You know citizen science, I'll talk about it a bit more when I go there, but it's the use and the cooperation of the beekeeper with the scientist. Then all the issues that encounter you when you start sampling. How much do you sample, when do you sample, how do you store it, I'll show you. Then the data collection, pollen analysis is also very important, I'll show you later. Modeling, what's the world today without modeling, and extension and dissemination. So this is all covered in this project. Thinking about the honeybee colony as a tool for biomonitoring, you can imagine you have a network. You don't only have a network, a European network, with thousands of colonies spread all over Europe, but it's a network worldwide. There are honeybee colonies all over the world, and all these colonies do the same. And in potential, all these honeybee colonies are biosamplers of not only honey and pollen, but also from the environmental pollution, including pesticides. taking advantage of this and asking beekeepers to help you, this the citizen science, of course you have to have very clear structures. So in this Insignia project we have a picture manual with very clear instructions, what should the beekeeper do. We have YouTube instructions. Every beekeeper that's participating has a toolbox, of course. You need tools to make your sampling. There's a live survey to see how interact with the beekeeper. Of course, there's communication on the dissemination. As it is on the interaction of the scientist and the beekeeper, this is also a very interesting social interaction. How can you keep the beekeeper involved in this study? How can you make them actively participating? Well, this part is covered by a sociological study, and of course there are rewards for the people that are helping us. So it's the beekeeper who doing the actual sampling. Going to work package 2, we have the sampling methods, and it must be done non-invasively. And first, let's see what we are talking about. We're talking, when you want to sample honeybee colonies, about 4 matrices. You can sample honeybees, you can sample pollen, wax, and bees. Now, this is focused on pesticides. And where do you find the pesticides inside the honeybee colony? You find them in the wax and you find them in pollen. You hardly find them in bees and you hardly find them in honey. And I don't have to explain you why you don't find them in honey, at least in very low amounts, and in bees. But wax acts like a sponge on pesticides. It's a chemical treatment. And we find with a medium of 60 in wax on about 40 ppm. And in pollen on 60 ppm. And to put it in perspective, this 40 and 60 ppm is not 1% of what's toxic to bees. It's about per mil, so 1 part of 1,000. So in that low amounts, these pesticides can be detected in wax and in bees. And of course, there are outliers, you see it, but this is the medium of a large number of studies that has been done by Reed Johnson and co-workers. So, honey, not important, focus on pollen brood and not on bees, and wax and pollen. That's where it's all about. Is honey a suitable matrix? No, it isn't, because there are hardly any pesticides in it. Are bees suitable matrices? No, they aren't, because we don't want to kill bees and we don't have that many pesticides in it. So, is bee wax a proper matrix to use for this? It should be, but there are more presentations that show, and we know, that most wax that we have that's circling around is contaminated by a lot of pesticides. So we don't use this. Can we use pollen? Of course we can use pollen, and we will use pollen. We will use pollen at random sampling, so take it in a week, 1 day a week, so you don't take too much pollen, and you don't interfere with the foraging activities of the bees. And we're going to use those pollen for pesticides, residue analysis, and for pollen identification. Come to that later. You also can harvest pollen not only 1 day a week, you can use it constantly by a special pollen trap designed in Denmark, where only part of the pollen is trapped. So there's a continuous flow of pollen inside the hive, and part is trapped. Also, these pollen will be analyzed for pesticides and pollen identification. Bee bread, into that later. Bee bread, pollen stored by the honeybee colony, is also sampled for both analysis. And then we come to the pesticides, and there are 2 ways to find. If you don't want to use wax, we have 2 alternatives. One way is and we are designing it a special strip. It is more a bit like a bivalve or a Abistan strip, but it does not release something. No, there are special chemicals on it, special substances that bind pesticide molecules. So inserting this strip in a D lane, so the lane between two frames, bees pass it, and we know that there's a lot of in-hive exchange of pollen and pesticides among all bees, so thousands of bees will pass there, and many of them will be adhered to these strips. We use this pollen, and we have this one, the beehive tube. And beehive tube is also a non-invasive sampling stuff, so you can use it inside the hive, but you can also force bees to enter through a tube. And when you line this tube with special materials that adhere part that's on the bees, you also sample them without killing bees. So these are the new sampling ways. Pollen, know about it, but it's the new non-invasive sampling ways, the in-hive strip and the beehive tube, the tube that bees pass entering the hive. Okay, then you have taken your materials, you have your strip, you have the pollen, and then the beekeeper has them. It has to go to the laboratory. How do you do that? What's the deterioration time of pesticides? In pollen, we don't know. So these are these questions. Do you have them in plastic bags? Do you have them in paper? Do you freeze them? Do you have them in the fridge? Do you dry them? Do you bring them directly to the laboratory? Or do it by post? Or do it by airplane? No, we don't know. We have to find out. And we will find out in the first year, this year, of this study. Because in this year there will be studies in Denmark, United Kingdom, Greece and Austria, trying to combine what's the best matrix, what's the best strip, what's the combination of pollen and all these matrices. We do this in these countries and evaluate them, and next year in 2020 there will be a kind of ring test for the best practice to use honeybee colonies as a monitoring tool in 9 countries. You see, it's a real European project, and it ranges from Latvia till Greece. Then we have the pollen, and we have the residues analysis. But it's a new project, and we want to use new methods. Identifying pollen is, you can do it by microscope and morphology. It's a lot of work, and now we're also working on the meta barcoding of the identification of pollen. It's the PCR method. Very complicated. I'm not a molecular biologist, so I can't explain it, but we all know the principle of this test. And the pesticides will also be analyzed in these laboratories with liquid chromatography and mass spectrometry as well. 2 laboratories, one in Spain and one in Greece. Coming to work package 5. When we have all these data, we know what kind of pesticides are brought in by the bees, we know what kind of pollen are brought in by the bees, so we can use a kind of pesticide exposure modeling, because all, and I didn't mention in this slide, but we also do some site studies to see is there any relationship between the foraging activity and the size of the colony, how many bees are coming in. And there is a relationship, so you don't have to count every day all the bees that are coming in. When you know the colony size, you know how many bees are more or less in a colony, you can predict the foraging activity. And then you can link it to the amount of pesticides that you find. So you can make a kind of risk map because you have the pesticides and you have the pollen. You know where the bees are foraging. And modelists can use all this data for modeling and make risk mapping. The European Union is also very keen on, is there only pesticides application of the legislated pesticides, or is there also non-authorized pesticide use? We know there will be. And this is also a way to find out, can we find pesticides that are not authorized? Having the data of the pollen, we can check if the Corina database of land use is still correct. And if not, what should be done to make it correct? Well, this is all done with statistical help from the University of Strathclyde in Glasgow, United Kingdom. And then we also can make a list of the phenology of the bee plants. So we expect a lot of data coming from this project. Brings it to work page 6, the dissemination and extension service. Why should you do studies? Why should you ask beekeepers to help if you don't give them the tools and make them know what's the importance of their role in it? So we have a website, www.insignia-EU. There are introduction articles in the countries where people are participating. We have YouTube, and I check if it works. Yes, it works. Also on the website, this will also probably be on the YouTube, and explaining what this project is all about. And at the end, and that's a final report of this Insignia study, and we hope to have this in 2021, is a final apiculturist citizen science protocol, where all the details, how can you ask beekeepers to participate, what tools do you need, what do you want to have, how do you want to have it, how does the beekeeper has to sample, how does he has to store it. All these simple questions that has to be answered must be in this new protocol, and that would be great, because at the end it's not that hard to take a sample. It's hard to have a proper sample, and it's very important to have this good sampling handling, and that's why a lot of attention is paid to that part. And this brings me to the end and show you the consortium. Can't name them all, but it's from, see, the Netherlands, Austria, the Graz University, Fanny Hachina from Thessaloniki, Norman Gernick, Alison Trace, Stratford doing the statistics, Alison Pinto and her co-workers doing the pollen things, Ivo Rusink and Bavco doing the modeling. In Italy, here Rome, Giovanni and Marco, working on this research topics. Greece, residues analysis. Spain, working on this in-hive passive sampling strips. And quality control. And Denmark, doing the dissemination. And also from Belgium, Latvia, and Ireland. And at the end, we hope to have good results. We hope to have a very proper and very good protocol, and I think we will achieve this. And thank you for your attention.